Go.
What if I told you there's a way to test almost anything? The scientific method is the way to do just that. In life, our worst enemy is our memory. And for most of us, it's been a while since we've studied the scientific method, so I'd like to use this speech today to give a way to refresh the memories or give some new ideas about it. The way I will be presenting this is by giving an example of a test that was done using the scientific method and take you step by step of the process. The first step of the scientific method is making an observation. And for my test that I'm doing, that is observing how well sugar mixes in water. It can be, observations are done every day by everybody in everyday life. And that can go from looking at the sun to how the wind blows and the time of the year, the seasons. And after you make an observation, you ask yourself a question. Usually, how does this work? Why did it work that way? Why is this happening? And for my test that I'm doing, that is, why does sugar mix in water depending on the temperature? This question is usually taken to the next step, which is forming a hypothesis. A hypothesis is a suggested explanation of something, explaining why, your point of view on why something happened. And forming this hypothesis around the idea of sugar mixing in water would be saying that sugar mixes better in hot water than it could in cold. And after you form a hypothesis, you go to the next step, which is testing it. Testing it involves many different ways, and that would be you get a glass of hot water and a glass of cold water, and you get sugar and put the sugar in both glasses, and you mix them together, and you can drink them. You can use microscopes to test them. You can observe them in many different forms and fashions to determine how well the sugar mixes in hot water or in cold water. And sometimes you run to a point where your hypothesis was a wrong explanation of what happened. And when you test it, you realize that. So therefore, you need to go back and ask yourself another question. And that'd be, why did it not work? What can I do to fix that? And then you reform your hypothesis and you retest it. After testing, you analyze what you come up with, your data, your information. And that would be like the temperature of the water. And you can show that on graphs like this, the temperature of the water, the amount of sugar you put in the water, and how the results turned out. And you usually make graphs, you can write papers about it and explain what happened. And after analyzing your data, you should usually get it reviewed by a professional or your peers or a big organization. They can test it and tell you if you made a mistake and that you need to go back and fix it and rewrite your hypothesis, retest it, reanalyze your data, and then you can send it back to them. Or if you do it, your test, and it turns out to be a big success, it can become a theory, and then from a theory it can become a law. And those usually are big impacts on the world today. Now that you know more about the scientific method, I have shared with you how to make an observation, how to ask yourself a question, and how to form a hypothesis, test that hypothesis, and analyze your data, and then get it reviewed by peers or any other people. I hope I was able to refresh your memory or add any new information to your knowledge about the scientific method. To learn more about this, more than just from me myself, you can ask Professor Alan Landward, the life science biology teacher. The book we use in his classroom, Concepts in Biology. Or you can go online to middleschoolchemistry.com, and they have more examples of different tests to be done. And also on sciencebuddies.com. They have pretty much the same exact way I did this. Thank you.